Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arman bin Abdul Manah. I'm from Group EE2414C. Today I will present about our lab, which is ARM Assembly Language Programming, Data Transfer, Data Processing, and Addressing Modes. This is for ECE 521. 521. Okay. For this lab, the objective is to make sure that all students are able to write simple assembly language programs for the ARM microcontroller using data transfer and data processing instruction and addressing modes. Besides that, we also need to execute the program using an ARM KEIL editor, assembler, or simulator. Okay, for this lab, we have 6 questions that we need to solve, and we need to execute all of the exercise of the question in exercise. So this is the exercise that we need to solve. All the program in the exercise must be written and assembled using the ARM KEIL assembler or simulator. To observe the result, the program must be compiled and executed in the simulator. The contents of the affected registers and memory locations should be examined through single stepping or breakpoint setting. Okay. So the first question in the exercise is we need to write a program that will store 0x 0 multiplied by 3 0 into R0. That means that we need to set this value into the R0 and then copy the content of R0 into R5 and then save data 0 multiplied by 4578561 into memory location 0 multiplied by 4000030. Execute the program and explain the difference in the results. Also discuss the addressing modes of each instruction used. Okay, for the question 1, we need to set first the R0 is 0 multiplied by 30, and then we need to copy this content into R5 for line 6, and we need to then save data 0 multiplied 4578561 into memory location. Then we set LDR is R1 is equal to 0, the value in the question, and the LDR R2, the value in the question. Okay, then we need to store the memory. Okay, so when we want to execute this program, we need to make sure first we set the simulator at here, tick here, and fill it the debug file, and then okay, then we can start build first. If no errors, we can start debug right now. No errors, and we can start debug. Okay, for the result of this coding, this address is for this question, the range of this, and then we click at our coding, we highlight at first line of our setup, line 5, and then we highlight here, we click first. Before that, we can see the value at register here is not the same like our coding. When we start, click here and step, we can see that the value of R0 change to the value like our program. This is so that is our value. Then we step again to see the second line memory R R0 into R5, and we can see at R5 is the value is same like our first value. And then we step again, we got the R1 value, we got R2 value, and then we store. Okay, so that is all about question 1. Then we move to question 2. We will move to question 2. Wait a minute. So we need to always be careful with this KEIL software because it is really sensitive about the folder that we save our coding. So this is my question 2. Open my Okay, so this is my coding for question 2. So first of all, the question need ask us to write and execute a program that will add 0 at 20 FE 5690, 0 at FE 123 and 0 multiply 34589 710 and save the sum in register R7, record the charge in CPSR as well. Okay, so we set first the value of R1, R2 and R4, and then this is the addition. So when we add R1 and R2, we will get the new value in R3, and then it is the same step. We add R3 and R4 and we will got the new value R7. Okay, to execute this program we need to build first to check no error, and if no error we can start debug right now. Okay, when we after it show our result, this is our address for this coding, this question, and then we can see here no value same as here. So we highlight line, first line, and then we click here and we step. When we step, we will see the same value as our coding, the value of R1, and then we step and we got the value of R2, same as our program, and then we step again, we will got the value of R4, same like here, and then the addition, like I said before, we step and we will get the new value of R3, which is R1 plus R2, and then we step again, we will get the new value of R7, which is R3 plus R4. So that is all about the question 2. We will move to question 3. Stop debug, and I will close because I take it as my new project. Open project, my folder of question 3 here, and then I open. Wait a minute, open, and okay, this is my coding of question 3. So question 3, we need to write a program that will store 0 multiply 2936 FEDA in R8 and then perform the following instruction on the content of that register 4 times. Comment on your result. First we need to set we'll store in our we need to do a SR, LSL, ROR. Okay, so for first of all, we need to build, and then no errors, start debug. Okay, for this question, we do not need to set the address of memory. Okay, so we can see here the value, the difference value between our coding and the register here. So we need to highlight our program and then we check, we step here and we will get the value of R8, same as our coding. And we need to repeat for 4 times to ASR, LSL, ROR. So we step 1, 2, and 3. And then we will get the answer. So this is the result of question 3. Next I will go through to the question 4. Question 4. Sorry, wait a minute. Okay, this is my coding of question 4, which is we need to write a program that will perform logical or 0 at 6398 with 0 as 1 DFE. Execute the program and comment on the results. Write a program on the result. Okay, so we build to check if no errors. We can start debug right now, and then start debug, and we can see the result here. So we, as before, we can see the same value as our program first before we step the value. Okay, so we highlight here and we step for the line 5. We can see the value of R1 is the same as before, as here. Okay, so we step again 3 times. The value is the same as our coding, 00007 FFE. This is the value for this, and we will get this value. So that is the result for question 4. Okay, so next question 5. Question 5. I need to close all and then open project again. Question 5. Okay, so this is my coding of question 5. Question 5, we need to write a program that copy 12 byte. 12 byte. This is 12 byte that I have set. 12 byte of data starting from memory location 0 multiply 4004000 to memory location starting 0 multiply 400400 to 0 set manually the content of memory in 0x4004000 until 0x4004000 to be 0x01 0x01 0x02 and so on. Run the program and comment on the result. Okay, for this we set for the 12 bytes and start. We set the value of R1 and the value of R2. This is the memory location. Hashtag 1 is the memory location. So we will build this coding to see the result, and now we can see no errors and we can start debug right now. When we start debug, we can see we set the address of memory, and then we will get the result. The register here is not the same like our coding, so we need to start. We highlight first and we can see here, we can see the value of. Okay, so we step again, we will get the value of R1 is the same like before, like our program, and then we step again, and again until we can compare this. See. Okay, now strb, we go to strb, we go to sub subtraction, we compare, and then bne here. So that's all for the question 5. So we'll go through to the question 6. For question 6, for question 6, we'll open our folder. Okay, so this is what we call immediate addressing mode. So the question is, write a program to compare data in num into register R2. If the data is greater than 5, store the data in memory location 0, multiply for 00 to 0000, otherwise add the data with 0 at 60 and store it in memory location 0 at 400 to 0010. Before that, set the number with value 3. Use EQU instruction, run the program and comment on the result. Okay, so for this question, this is my coding regarding to the question. We need to use this hashtag num EQU for the value of 3, and then we build no errors and start debug. Before that, I already done my video, but it's too long, which is I record for 27 minutes, but I'm trying to do more fast than that. Okay, so this is my coding, my result of question 6. We can see here no value same like here. Okay, so we highlight here and we can get the value of R0 is the same like here. We can see the value of R1, and we can see the value of, we can see the R2 value, and then we go to BHI, and then we go to strd, we go to B, and then step again until the end of the coding. Is it here and here? So that's all about my presentation of our coding. So the discussion of this laboratory, I have a problem. The problem that I have faced is a lot of project make me in trouble to execute one by one because before that I save between I save in different folder, but I can execute I can execute the program because I survived that things and I got the solution. I need to open project and open file again one by one to avoid myself for making trouble to execute the program. Okay, so the conclusion is this laboratory make us really better to use KEIL software. So I'm really that's all for me. Thank you.